And welcome everybody to the Daily Space Weather Show. We've got our Ask a Particle Physicist segment tonight and lots more to cover. We've got a new sunspot or two rising in the southeast. We'll get to it. This is the past 24 hours from the Solar Dynamics Observatory. If that's not a close enough view, don't worry. Here's a little closer view for you. That should help. And again, we had two new sunspots just rise in the southeast. So here's a close-up of those two new sunspots. And we hope you are not deranged and angry about each sunspot that either forms or rises. They are doing wonderful things at mental institutions nowadays. But there are two new sunspot groups. We should have like an increase of about 24 sunspots coming tomorrow. Here's the past 24 hours. It's almost 24 hours. That's today's SDO continuum. And those sunspots will be counted before the groups on the western limb are able to set in time. So uptick in the sunspot number coming with those new sunspots. There's the SDO colorized magnetogram for December 8th to date. Pretty inactive sun as far as the past 24 hours. And by the way, these following pages are paid endorsements. So the Smash News Network, least busted name in news, does offer subscription services. You can find those at smashomash.com/smashteam. If you'd like additional content, sign up over there. You can get email alerts and, again, additional content. 4 different levels there: the bronze level, the silver level, the gold level, on the gold annual paid-up subscription. smashomash.com/smashteam. Another paid-up subscription is MANSA, which stands for Make America Not Suck Again. Because the best way to get out of a hole, folks, is to stop digging. This is apparently not any kind of conventional wisdom. It's very controversial to say to get out of a hole is a smart idea, and that you ought to do so by stopping the digging to get out of one. MANSA, Make America Not Suck Again. I'm wearing the sheet. I'm wearing the sheet. I'm wearing the shirt right now. There you go. MANSA, Make America Not Suck Again. Pardon my face. It was vanishing there. My head must be all full of space or something. I don't know. Make America Not Suck Again. Links below the video to our paid affiliates. Another one is the Hemp Lucid shop, hemplucid.com. Make sure you enter the promo code SMASHOMASH10. It'll save you as many % on your checkout at hemplucid.com. Again, the promo code SMASHOMASH10. It'll save you 10%, so make sure you enter that on checkout. Links below the video to the Hemp Lucid storefront as well. Another product you'll find there is the cheap sunglasses. Yes, some retro sunglasses. There you go. Available on our Amazon shop, amazon.com/shop/smashomash. Today's featured product of the day from the Amazon shop. It's in the Spacewear collection. Those are polarized, if you're wondering. And let's move on to the home page, smashomash.com, and welcome to the Neo Renaissance. Congratulations on realizing the channel exists. Welcome to the Neo Renaissance, etc., etc., etc. Press the things like share, like, comment. Thanks to our viewers who've done so. No eruptions happening at Iceland, and let's see where earthquakes indeed are erupting. First of all, Sakurajima is exploding, producing a 6,000-foot plume of volcanic ash. Activity has decreased at Mount Mayon over the Philippines. Luitolo is exploding, 6,000-foot ash plume over Lesser Sunda Islands. Merapi, eruption by ground observers noticed over East Java, Indonesia. Semeru exploding, 19,000-foot ash plume. That's an uptick there at Semeru for the past 24 hours. 10,000-foot ash plume from Dacono. Popocatépetl, no volcanic ash currently observed. Sanchaguido exploding 14,000-foot ash plume. Fuego exploding flight level 150, 15,000-foot ash plume. 21,000-footer from Nevado de Ruiz. Sangay in Ecuador exploding flight level 200. And continuous emissions from Sabancaya are a reminder. Folks, please don't pole vault the caldera. Don't pole vault the caldera. It could be unhealthful. And next, let's get to earthquakes. There are the past 90 days, and it's been quite busy over the past week or so regarding the shaky portion of the lithosphere there. Quite a bit of activity going on, seismically speaking. Here we've got the Solomon Islands had a 5.8 earlier this morning. That was at at 41 after 0 hour there. The largest, I think that's the largest quake, a 5.8 in the Solomon Islands. Looked like it did a bunch of damage also. Philippines also had a 5.1 as continued aftershocks continue. South Sandwich Islands had a 5.2. Vanuatu had a 5.6. Then a lull in the action until Tonga had a 5.2. Then Philippines had a 5.0. Papua New Guinea had a 5.5. New Caledonia had a 5.0. Vanuatu had a 5.2. Quite a bit of activity continues, folks. Again, let's hope some of these large quakes are not foreshocks. Fingers crossed on that, and let's get back to space. So here are the past 24 hours from SDO. We have had multiple coronal mass ejections going off once again. I think there may be another earthly directed one. We'll get to the analysis of that momentarily. First, let's get to some stats, starting with the 10.7 centimeter radio flux. So the 10.7 is now at 133 solar flux units. 133 is the radio flux. There's the 1-year graph depicted by the black line. The red line is the sunspot number. And yes, many of us do not believe that we are yet at solar maximum. So, expecting that to not arrive until about September of next year. We'll have to see what happens. Short solar cycles tend to be strong solar cycles. I'll just say that. Here is our Space Weather Enthusiast dashboard, and no space weather forecasts there. I think NOAA might be missing one. See our previous daily space weather videos for more details on that. Here's the Enlil spiral, and again, no real forecasts for CME impacts from NOAA. Our channel is showing some alternatives to that. Also, NASA not forecasting any incoming CMEs. We're pretty sure we've seen some. Again, see our previous daily space weather videos for that. And next, let's get to the last 4 hours of Earth's magnetic moment from space. So there's the space weather modeling framework for the past 4 hours. So far, things are quite quiet on the coronal mass ejection front. Solar wind here fairly gentle. It is geomagnetically calm in space to about 12 Earth diameters, which is approximately what the space weather modeling framework is modeling. Earth's magnetic moment from ground depicted here, depicting magnetic flux density, the units of which are measured in nanotesla. Earth's magnetic moment from the ground for the past 4 hours. Again, it is a geomagnetically calm situation on the Earth-based magnetic station. KP index currently at 1.66. 1.66666666, rounded to 1.67 is the KP index. KP 1.6. We got a bunch of missing data here. The latest on the ACE is about 2 protons per cubic centimeter for the solar wind density. Solar wind velocity here very nominal at 400 kilometers a second. The Discover here showing a little bit different returns, but not off by much. Less than 5 protons per cubic centimeter for solar wind density. Solar wind velocity here 425 kilometers per second in decline over the past 24 hours. Next are GOES magnetometers. Those are pretty smooth. There were some moments here where the GOES 16 and GOES 18 needed to maintain their orbits. That's the arc jet moments. The thrusters on the GOES 16 and GOES 18 create plasma. That can create plasma which can affect the magnetometers, so they are noted there in the data. And next is our top view ecliptic plane field plot. Earth remains in a North Pole oriented sector, kind of right in the middle of it, as you can see there depicted in green. North Pole sector for Earth's magnetism in the heliosphere. Next, line of sight ecliptic plane field plot. And the South Pole current sheet is probably about 2 days out yet, so no sector boundary crossing imminent. Here's our line of sight field plot. One of my personal favorites. If I had to look at only one piece of data, it might actually be this one right here, the line of sight field plot. Gotta love it. Shows photosphere magnetism in gray, green and red solar polar fields in green for north and red for south, and the solar B field in blue. Just fantastic, which brings us to coronal holes. So there you go. That's the situation with coronal holes, and we've got some much more well-defined coronal holes here. Moving into the Earth-facing strike zone. And here comes some coronal holes from SDO. There's the 211 angstroms. Gotta love it. Let's get a little bit closer, as we have a great view of one. I mean, you could say it's forming, but it's really just kind of rotating into the more earthly portion of the solar disk. There you can see that, quote, opening up. Although it could just be a perspective thing. Keep in mind, folks, the solar corona is very bumpy. So we'll get a little bit closer there. There's a little close-up for you. And we'll zoom all the way in. Great view of a, quote, opening, end quote, coronal hole. This one is close to the equator. It is likely to produce some high-speed wind. We're still probably 4 to 5 days out from that. Great aesthetic view there of a near transequatorial coronal hole system. Coronal holes, the source of the high-speed solar wind. Moving right along to sunspots. It's time for sunspots. And there's Rob's current sunspot number there. The Royal Observatory of Belgium showing about 129. Little decrease in sunspots. I was thinking that was going to come up today. It actually went down a little bit further. We are expecting that to come back up to about, should go to about 140 by tomorrow. So another little hiccup there in the solar cycle. Small increase likely in sunspot number coming tomorrow. Next, our flare probability monitor and scoreboard. We do have some increasing likelihood of large solar flares, especially in the southwestern limb. This area right down here, a series of magnetically complex sunspot groups are hanging out down there, and as they get closer to the edge of the solar disk, they become more likely to produce large flares. So that's the quick answer. Here's our SDO magnetogram for the past 24 hours. And here is our SDO continuum for December 8th to date. So not a lot of changes happening there. No major growth, no major decay of sunspots. A little bit of growth in that northeastern group. And again, 2 new sunspots just rose in the southeast. So not sure how complex those will be. Those will probably get named pretty promptly tomorrow. Again, expecting an increase in sunspots of about 20 by tomorrow's daily space weather video. And next to energetic particles and solar flares, we ain't got none. Proton flux remains flatlined. X-ray flux here has come up a little bit. We're back into a C-class background level of X-ray flux. It's about a C1.13 for the background X-ray flux. No major intensifications, only C-class flares in the past 24 hours. Here come SDO's data here, 131 angstroms. Pretty quiet sun for the past 24 hours. Again, likelihood of large solar flares is highest in that southwestern limb down there in the lower right of your screen. Also some possibility for large flares in the southeast, your lower left. Next, a star chart. That's what's going on overhead. We've got Jupiter and Saturn up there over Lehigh Valley, Pennsylvania. This is from skyandtelescope.org. We've also got a star chart. There you go. There's Vega. That star is going to come up here in just a minute. First, our solar system forecast, where we show you where things are today in the solar system, and also where things will be in a week. So there they are today. And we'll move this ahead 1 week. There's where things will be in 7 days as Earth moves into this side of the solar system with zero gas giants, making its way to a more lonely side of the solar system there as Earth catches up to Mars. Mercury catches up to Earth and Venus speeds away. Next, our astronomy photo of the day, and there you go. There's Vega. And also a periodic comet. So you might think it looks a little bit like the Millennium Falcon. It has to do with where material is blasting off of that comet. You've got multiple different things there. You've got an ion trail, you've got different chemical signatures, and you've got different dust plumes and different vaporization, sublimation patterns coming off of that comet. Pretty good one, pretty good image there of Comet 12P Pons. Comet 12P Pons. apod.nasa.gov. And let's get to our Ask a Particle Physicist segment. Yeah, it's time to ask a particle physicist a segment. So thanks to Eugene for tolerating the questions to a particle physicist. If you'd like to ask a question yourself, go check it out at smashomash.com/forum. You can ask a question over there. So here comes our Ask a Particle Physicist segment, but first make sure you press subscribe to Eugene the Philosopher. Maybe you'd like to hear about how pseudoscience is a political term. Maybe you want to hear about electromagnetism in space. Does the fact that electromagnetism in space mean that electricity runs the universe? Well, go find out yourself by watching the video. Eugene the Philosopher, and here it goes. Here's a little quick Ask a Particle Physicist segment. This is What is Mass? Take it away. Take it away, Eugene, the monotone from Minsk.
Okay, so the question was, what is mass? And I'll actually give you a definition that I like, that I've invented, but it's a bit of a poetic definition. It's not very practical, like a philosophical definition, or philosophical even, since I'm Eugene the Philosopher. But in order to understand what is mass, let's take a look at where it's appearing first and foremost. There's only two places really where it appears. It's like mechanics and gravitation. So in Newton's laws of motion, Newton's second law is formulated as such that mass is basically the proportionality coefficient between acceleration and the force. The force is acting on the body and the acceleration it receives from these forces. So this describes what basically the mass as a measure of inertia of a body, right? How reluctant it is to change its state of motion with respect to, the forces acting upon it. That's the first thing where mass appears, and the second thing is the law of gravitation, okay? Where you can see it's big G times 2 masses divided by distance squared, distance between them. So these are really two aspects of mass. So a mass is a measure of inertia, and a mass is a measure of gravitational attraction. And that's why sometimes, by the way, people talk about these gravitational masses in like they divide them in two, if you wish. So one property is like active gravitational mass, is the kind of the ability of a body to generate its own gravitational field, and passive gravitational mass, which kind of is a property of a body to sort of react to external gravitational field, if you know what I mean. But these are basically the same, right? But I mean, in some specific formulations of certain theories, you might perhaps make such a distinction. So there you go. Mass is a proportionality between the force and acceleration, firstly. That's Newton's second law. Or it is a property of a body to react to or produce gravitational fields. Okay? And we have the equivalence principle, which states that these two masses are the same. However, if you look at the laws themselves, here we have F equals ma, right? And here we have not just m's, and like, you know, some sort of spatial value, which is r in this case. Here was acceleration, but also g, right? So you might think about g, the gravitational constant, as sort of like or rather a square root of g, as a proportionality coefficient between the gravitational and the inertial mass. You might think about it in this way, but these m that we see here and here are considered to be the same. So basically, any disproportionality between these two masses, the gravitational and inertial one, is swept under the rug into this g. And what do we know about g? It's the worst known constant, in thick air quotes, constant of nature, right? It has been found that it actually might even change in time, like with this periodic 5.9 year oscillation. Okay, so maybe the equivalence principle is it's a little bit shaky, you know, because this g behaves really strangely. Like, we don't really know it very precisely, as you can see. Only 3 digits are known. The 4th digit is already under heavy suspicion, let's say, because these are the various measurements, and you can see that they don't really agree between each other. Okay, so maybe the equivalence principle is something worth investigating, let's put it this way, okay? But yeah. And so, what about my own definition? Well, it actually stems from the inertial property of mass. So, as Eugene the philosopher, I would define mass as memory about the state of motion. That's it. So, you have a lot of mass, it's really hard to change your motion. Your memory is really good in this respect. Some sort of, you know, like a hysteresis effect, you know, when you can magnetize a piece of iron, so it has a certain memory about the magnetic field. Well, in this case, it's the memory about the motion. It's like the remnant magnetism of previous motion, so to speak. And I'm saying the word magnetism metaphorically, obviously. Something like that.
So there you have it. That is our Ask a Particle Physicist segment today. Thanks to Eugene once again. Again, folks, don't forget to subscribe to Eugene the Philosopher. Help him out. And yeah, congrats, Eugene, on the recently reaching 500 subscribers. Let's get them to 1,000, folks. If you haven't checked out Eugene the Philosopher, check him out. Once again, thanks again to Eugene. Next, moving to coronal mass ejections and solar flares. I mean, just coronal mass ejections. We already did the solar flares, and that's been minor. So here are CMEs for yesterday. And we covered most of this yesterday. Again, see yesterday's video for more details about yesterday's CME forecasts. There was certainly a halo. Here come today's CME activity. And certainly some minor events. There was a CME that lasted an extremely long period of time. The one that came out of the north. Anyway, that's 58 frames from today. Let's take a look at some more imagery here. Let's add the LASCO C3. There's C3 on the right. Let's get in a little bit closer there. And we'll let those play through. We have the C2 a few hours ahead of the C3. So there's one out of the north. And then a big lull in activity there. And then a second CME out of the north mostly, but it has a halo-like effect. So that one looks like it is earthly directed. Let's bring this C3 back first. So that one there, the one that emerged from the coronagraph, that must have been at about 1400 today. There you go. Looks like another CME likely to arrive late in the day on the 11th into the 12th. So late in the 11th, more likely early to midday on the 12th. Another CME on the way, folks. We'll also show stereo A. I suspect it's going to confirm what I just stated. And it certainly does indeed look like a partial halo. So most of the ejecta will miss to the north and to the west, but there is some that will hit. So multiple CMEs showing up here. And look, people go on vacation. Sometimes people miss stuff. You have to look pretty hard to catch all of these. And here it comes. There's 1200. And there comes that CME. So that is the one, once again, that likely has some earthly directed components. Certainly a halo-like discharge there happening. Portion of that CME likely to be headed toward Earth. Let's see what we've got when we look at our own custom videos. So these are 24-hour videos. All right, that one might be far-sighted. So let's take a closer look here. Here's a little extra zoom. And if you can tell me where that CME is coming from, definitely let me know in the comments. I'm not so sure that's on the Earth side. I have a feeling that might be on the far side. So, and that is a thing that happens regularly. We see halo eruptions on the far side of the sun. At the moment, I'm not seeing that. Okay, you know what it is? It's this very long duration CME from up here. So that actually could have earthly directed components. It's actually this massive filament. It just hung out in the corona for so long. This far side bit over here, you can see that slowly making its way out. Look up right up here. That portion of it right there. So I suspect that is on the far side though. So, but it was part of this overall event, that filament. It's still not completely ejected. It's just making its way out now. So that could still have some earthly directed type ejecta, because check it out. Right in here is where that originated from. That could be just one massive filament there. So that was an interesting coronal mass ejection, to say the least. And here you'll see this filament right here becoming unstable, and whoops, there it goes. And once again, part of it, here it comes. So multiple CMEs on the way again, folks. They'll all be minor impact, but nonetheless impacts. So there's that. Here's the grayscale imagery. We do have a very substantial plasma filament there in a very odd orientation, I might add. Just the shape of this filament right here, very strange. I suspect it's probably unstable because of how it's sitting right now. A big S right there on the Earth-facing portion of the solar disk in plasma filament glory. So, dag. Just berserk activity, folks. Berserk activity. And here's 193 angstroms. So this filament up here mobilizing for a long, long time and then finally blasting off by the mid-afternoon today. And before we get the bonus features, there's the tail end of that. It's actually still going on. Part of that is splashing back down. Part is probably ejecting there. So a very, very long duration CME event there that lasted actually over 24 hours, total duration of that particular plasma filament. It moved all around and then it blasted off. Just a berserk plasma filament. Really taking its time leaving the corona this time. And here come bonus features. First, satellite charging hazards. We ain't got none. It's smooth sailing for satellites at the moment. There's the global view. Electron flux here, just right around warning levels there for the GOES 18 and GOES 16. GOES 16 a little below warning, GOES 18 a little above warning. Ta-da! There's the 1-year graph. Electron flux at kind of high levels. Here is the forecast model. Never got quite to high as expected. And we do have some CME impacts coming, so you can expect to see this to be, might be a little bit more, it might be a little bit less predictable than it looks. I'll just say that. But that's NOAA's forecast. The green boxes are the forecast. Next, the ionosphere. And we'll show that. Bureau of Meteorology, Australia. And we've got geomagnetically calm conditions in a fairly run-of-the-mill looking ionosphere. Here's the anomalygram. Might be more definitive to you. I don't know. Actually, we are having some little anomalies around there. Some little odd, large variations around the South Atlantic anomaly especially. Seeing some rather sharp high-frequency anomalies happening over North America, actually. So that's interesting, a little bit out of the ordinary there. Here's the latest image, 2300 Universal Time for both. Next, the Wham! Last Christmas, I showed you these graphics, but that's really not true. I can't gaslight you. This year, we'll play these graphics. We hope you find it special. Special. Anyway, that's the Wham, the ionosphere, the whole atmosphere model, the global ionosphere nowcast. Next, the total electron content forecast. And don't forget to press the subscribe button. And don't forget to follow us over on Twitter. Twitter.com/smashomash. Or you could use x.com/smashomash. I guess it's less keystrokes. Not a brand, but less keystrokes. So there's that. And here's the CTIPE, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. The most likely places to see GPS errors. I'll let it play through again. It's literally a count of electrons from the ground level up to your GPS satellite at about 12,500 miles of altitude. So there you go. People who live on the equator know their GPSs don't work throughout the late morning and early afternoon. Next, the latest continuum and latest SDO magnetogram. Here are two new sunspots that just rose. They look like alpha-class sunspots, which makes them unlikely to produce large solar flares. The most likely place for large solar flares is What the hell happened? There we go. The most likely place for large solar flares is around this area. Yes. Yes. I don't know why I'm having trouble picking the right buttons today. It's been a long week, I'll just say that. So those are the most magnetically complex sunspots. They are approaching the western limb. Also, those things make them good candidates to produce large solar flares. That's where we'll be having a good old-fashioned solar flare watch. And before we get to the ever-popular meteorology segment, press the like button, or else there will be ramifications. Hopefully not ramifications for your soul. No, everything's a ramification for your soul. I was just kidding. Yeah, so press the like button. If you're new to the channel, press the subscribe button. If you don't, we will find your IP address and we will rain bot calls down upon your soul. Imagine spending the rest of eternity descending an ever-deepening and darkening abyss of bot calls and boring chats where bots want to know if you'd like to talk about crypto. Well, that's your fate if you fail to press like. As we approach the darkest days of the year. The winter solstice, you know, the darkest days of the year. Yeah. Don't get in the darkest days of the year by not pressing the like button, thanks to everybody who has. And let's get to meteorology. Here at the Smash News Network, least busted name in news. Yeah, that's it. So we got massive pressure gradients spread across the center of the U.S. here. Actually, two massive pressure gradients if you count the one in the east. And that's creating the weather conditions that are running the show in the U.S. right now. And some of that is heavy precipitation happening here along this pressure gradient. So that's what's causing it. If you think that's HARP or chemtrails or contrails or cloud seeding or geoengineering or anything like that, you shouldn't think that, because that isn't what's occurring. Anyway, there's some low pressure zones in the North Atlantic, some high pressure zones over Siberia. A massive anticyclone, a huge pressure there on the atmosphere. And down here you'll probably find the lowest pressure there, around 950, so quite chilly in the Southern Ocean actually right now as well. Anyway, we won't talk about that too long. I wouldn't want to have the channel deleted or have the video demonetized for talking about sea surface temperatures, would we? No, that couldn't be a thing, right? I don't know, so I just don't really care anyway. So anyway, there are the surface winds of the east. Here are the jet streams of the central world. There you go. Surface winds of the west. And there are the jet streams. And let's take a look at clouds and fog. Once again, clouds rapidly forming over Brazil after the sun sets. And here we've zoomed in on the pressure gradient that we showed you earlier. You can see where there's air moving in and then, you know, colliding with lower pressure air and trying to reach static equilibrium as things do in nature. And some chaos happening there over places like Utah, like northern Utah especially. There some huge pressure gradients there as the atmosphere struggles to reach static equilibrium. Next, rain accumulation for the next 3 days. There's the Euro model. Notice all the flooding up the entire East Coast. Here's the GFS model. So we'll have wildly warm temperatures and wildly wet. It's going to be wild, wet, and warm in the east. So well above normal. We'll get to it First, our weather.gov map, a bunch of flooding. As you can see there, flood watches up the East Coast. Weather.gov is where to get your warnings. Too many counties for us to cover. Here come some forecasts, starting with the GFS 72-hour. Pressure and precipitation. Ta-da! Ta-dow! I'll say. Here is total accumulated rain precipitation in inches. GFS 72-hour model style. Ta-dow. No, my name is Tadow. I own this. Y'all honkies know me. Y'all honkies tearing up stuff. Here is the total accumulated snow depth change forecast in inches. Second wave of snow to hit the northern Rockies there after the first one. That'll bring the most snow to Idaho. And anyway, there's the graphic. Some snow coming to Pennsylvania once again. The East Coast is going to get a little bit of a coating style, maybe up to an inch, if you're lucky. 72-hour GFS total accumulated snow depth change, and here is the GFS 72-hour temperature anomaly forecast. Again, very warm temperatures coming for the next couple of days, although it will be accompanied by quite a bit of moisture. Next, lightning. And it's pretty calm over the U.S. You're not going to see a whole lot of lightning in the wintertime. Let's move on to a real-time lightning map to briefly show you the global lightning map view. There is lightning, according to lightningmaps.org. Here's U.S. Doppler radar. And by the way, folks, lightning does strike twice. Imagine a magnetite deposit, and then imagine lightning striking it, and then you thinking it's not going to strike twice and getting on the magnetite deposit. How do you think that works out? Here is clouds and fog over the U.S. There is water vapor. It shows the dry air. It shows the moist air, and if you know how to read that map, you can pretty much forecast the weather by itself. There is vertical motion in the air column. Known as ground-based systems called Doppler radar. There is the space-based infrared radiation in the short wave, showing clouds and fog even at nighttime. And here is the water vapor map, showing the water vapor as in all of it. And here is me becoming very fatigued and ending this video. So thanks for tuning in. And while I'm gone, may that solar wind be at your back during the darkest times of your lives. Or something.